Hi, I'm Lisa Fortier, professor of equine surgery at Cornell University and editor-in-chief at the AVMA. Today, I would like to share with you some scientific research supporting Thrombinator thrombin as an autologous fibrin sealant. There are several applications of fibrin sealants in musculoskeletal surgery, including cartilage and osteochondral repair, where it acts as a sealant for osteochondral fragments collected using graft net plus biocartilage from arthrex. Fibrin sealants can further be used to enhance the bony incorporation of osteochondral allografts. In shoulder procedures, fibrin sealants can be applied to augment bone graft procedures used during rotator cuff repair. There are several allogeneic fibrin glues on the market, primarily indicated for vascular surgery. Numerous studies show that they are quite comparable to each other with respect to adhesive and frictional properties. History would teach us that commercial fibrin glues are not optimal for cell migration, cell proliferation, or matrix formation. As previously mentioned, they are designed as sealants in vascular surgery. More than 25 years ago, it was shown that chondrocyte extracellular matrix was greater in cryoprecipitated autologous fibrin compared to tissue. Further studies demonstrated that chondrogenesis and proliferation of bone marrow and adipose-derived mesenchymal stromal cells are inhibited by commercial fibrin. And even when commercial fibrin is diluted to 25%, cell migration is enhanced, but this dilution of commercial product is not practical in the OR. The Thrombinator thrombin device provides a method to generate autologous thrombin in less than 15 minutes. 0.1 ml of 10% calcium chloride and 4 ml of biofluid is added in the first step. In the second step, these volumes are the same ratio, but they're doubled. So 0.2 ml of calcium chloride and 8 ml of biofluid are added. After you have withdrawn the thrombin-rich serum, it is dual injected with a fibrinogen source such as platelet-rich plasma, platelet-poor plasma, or whole blood. The thrombin and fibrinogen react within about 5 to 15 seconds to rapidly form a clot at the point of care. Thrombinator works by initiating and supporting the clotting cascade. The intrinsic and extrinsic coagulation pathways come together in the common pathway to activate factor 10, which is designated as factor 10A, with the A indicating the active factor. Factor 10A activates prothrombin to become thrombin. Thrombin then converts fibrinogen to fibrin, resulting in a fibrin mesh clot. A fibrin clot generated with Thrombinator thrombin and PRP as a fibrinogen source supports all three components of the trilogy of functional tissue regeneration. It allows for cell migration into and within the fibrin clot, provides growth factors, and as a fibrin clot, provides scaffold support in tissue repair. We performed these sets of experiments to first understand the mechanics of a Thrombinator thrombin plus platelet-poor clot compared to commercially available fibrin, in this case Tisseel. But recall that in other studies, the mechanics of Tisseel are comparable to other allogeneic fibrin glues, so the results that I'm about to present are broadly applicable to other fibrin glues. In the mechanics study, cartilage discs were sandwiched between cartilage explants with fibrin glue and pulled to failure. The effect of sealant on adhesion of biocartilage graft to cartilage was determined by quantifying microstrains at the graft-cartilage interface using an in vitro cartilage defect model subjected to shear loading at physiologic strains below failure thresholds. Fibrin sealants are generated using dual injection syringes with one syringe containing a fibrinogen source and the other containing thrombin. In this biomechanical study, 5 different combinations of fibrinogen and thrombin sources were used as seen here. These constructs were then pulled to failure and subjected to shear strain. In pull-apart or tensile failure, the all-autologous clot of Thrombinator thrombin with platelet-poor plasma as a fibrinogen source, shown here by the yellow circle, had similar strong pull-apart strength with no differences in tensile failure compared to the all-Tisseel group. We next wanted to know how these sealants performed in shear stress in modeling cartilage repair using biocartilage. These 3 images demonstrate microstrain analysis testing of articular cartilage in compression plus shear with native cartilage in the leftmost panel. Again, the all-autologous sealant of Thrombinator thrombin with platelet-poor plasma as a fibrinogen source improved mechanics compared to the all-Tisseel group. PPP plus Thrombinator thrombin sustained lower strains through the graft-cartilage interface throughout the depth of the construct compared to Tisseel, which was much more brittle and resulting in failure at lower strains. This is really important because we know from previous work in the Bonasser laboratory that approximately 90% of strain is dissipated in the top 50 microns of articular cartilage, emphasizing the importance of the surface layer. In this study, it was noted that the PPP and Thrombinator thrombin clotted more slowly than TisSeal, suggesting that the fibrin was allowed to percolate deeper into the repair tissue, thereby providing more stability throughout the tissue depth. Knowing that Thrombinator thrombin plus platelet-poor plasma provided optimal biomechanical support for cartilage grafting, this next study was aimed at understanding how this all-autologous fibrin sealant might affect cell adhesion and migration in an ex vivo model of cartilage repair using biocartilage. The results demonstrated that both chondrocytes and MSCs remain viable, adhered, and migrated on biocartilage Thrombinator thrombin cartilage repair construct, demonstrating the biocompatibility of this grafting procedure. Compared to commercial fibrin glue, it will not settle as fast or as stiff, but this is an advantage in cartilage repair because Thrombinator thrombin will percolate into the depths of the tissue and provide a biological scaffold with biomechanical support. In summary, Thrombinator thrombin with platelet-poor plasma as a fibrinogen source is superior to commercial fibrin for cartilage repair both mechanically and biologically. With these biological advantages, there are many surgical applications for Thrombinator thrombin that can be considered. Thank you.